In this video lesson, we are going to learn how to find the surface area of pyramids and cones. So let's go ahead and take a look. So this would be a net of a pyramid. And so the base of this pyramid is rectangular. And then it would meet at one point. So when I unfold it, I have this base in the middle here. And so to find the surface area, we'd have to find the area of the base plus we'd have to find the area of all of these triangles. So plus area of all triangles. So that's how we're going to use this formula. Really, we're just finding the area of all the surfaces. So let's take a look at an example. We want to find the surface area of this hexagonal pyramid. So we first want to find the area of the base. Well, the base is a hexagon. And looking at my picture, I can see that the apothem is 4. And that's really all I know about the base. Well, if I want to find the area of the base, remember our formula is 1/2 the apothem times the perimeter. So I need to go ahead and find the perimeter of this hexagon. So I'm going to draw a right triangle right in here, and I'm going to redraw it below. The apothem is 4. Since this is a hexagon, I know that all of my interior angles are 120 degrees, but I divided it in half, so this is just going to be 60 degrees. I'm going to use what I know about 30, 60, 90 right triangles. And I know that my pattern is whatever side is across from 60 is in the ratio of x square roots of 3. Well, I need to find what's across from 30 so I can find the perimeter. And I know whatever across from 30 is x. Looking at my picture, I know the side across from 60 is 4. So I get x square roots of 3 equals 4. I'm going to go ahead and find x by dividing both sides by the square root of 3. I can't have a radical in the denominator, so like our previous unit, I'm going to go ahead and rationalize, meaning I'm going to multiply by root 3 over root 3. And so I end up with x being 4 root 3 over 3. So that's this piece right here. That's going to be 4 root 3 over 3, but I have 2 of them. So here's another 4 root 3 over 3. Well, let's talk about our formula here. We've said area of the base is 1/2 the apothem times the perimeter. So area of the base is going to be 1/2. The apothem is 4. To find the perimeter, there are 6 sides. And I know one side, I'm going to calculate that, is 4 root 3 over 3 plus 4 root 3 over 3. Well, that's going to be a total of 8 root 3 over 3. So we can simplify this. Half of 4 is 2. And then over here, 6 divided by 3 is 2. And times 8 is going to be 16 root 3. Well, 2 times 16 root 3 is 32 root 3. So there's the area of the base. Now let's think about these triangles I have. Well, the base of the triangle is the same as one side of the hexagon. And so I know that's 8 root 3 over 3. And now I need to find the height of this triangle. And since it's an equilateral hexagon or a regular hexagon on the bottom as the base, I know that all my triangles are congruent. So I only need to find the area of one triangle and then multiply it by 6. Well, this is called my slant height. And the slant height in my three-dimensional picture is this diagonal that's formed by the height, which is 10, and the apothem, which is 4. So here is 10, here is 4. Here is my slant height, which is the same as the height over there in my triangle. Well, to find that, I'm going to take 10 squared plus 4 squared equals x squared. I'm just going to use the Pythagorean theorem. So 100 plus 16 is x squared. 116 equals x squared. In order to find x, I'm going to go ahead and take the square root of 116. And I get 10.77 is my x value. So this is going to be 10.77. So to find the area of a triangle, well, that's 1/2 base times height. So it's going to be 1/2. The base is 8√3/3, and the height is 10.77. I'm going to go ahead and figure out what this is as a decimal. So I'm going to take 8 times the square root of 3 equals, and then I'm going to divide that by 3. I'm going to multiply that by 10.77, and then I'm going to multiply it by half. And so the area of one of the triangles is 24.87. So let's put it all together. In order for me to find the surface area, I'm going to take the base plus all of my triangles. Well, we know the base is 32 square roots of 3 plus I have 6 triangles, and each triangle is 24.87. So I'm going to take 6 times 24.87. I'm going to put this all in my calculator. I'm going to take 32 times the square root of 3, which is 55.43, plus 6 times 24.87 is 149.22. So when I take 55.43 and I add 149.22, I end up with 204.65, and my units are centimeters squared. That one's a pretty tricky one. A lot of involvement there because the base was a regular hexagon. But there you go. All right, let's take a look at one more. Let's find the surface area of a cone. So we know that a cone looks something like this. And when we open up the net, we have the base. And in this situation, the base is a circle. And so area of the circle is pi r squared. And then we have this lateral area. Okay, so this is the lateral area. And to find the lateral area, our formula is pi r L. And L, and it's a cursive L, L is the slant height. So plus pi r L. If we were going to look at our three-dimensional cone, here's my radius. The height has to come down at 90 degrees. So here's my height, which means that the slant height, L, is on the side or on the edge of the cone. So let's go ahead and take a look at this example. I want you to find the surface area of that cone. So go ahead, pause the video, try this, and when you're done, come back, we'll see how you did. All right, welcome back. So for surface area of a cone, it's pi r squared plus pi r L. My radius is 5. So pi times 5 squared plus pi. Again, my radius we said is 5. And the slant height would be this diagonal right here, which is 13. So 5 squared is 25 pi plus 5 times 13 is 65. So we have 65 pi. And I'm going to go ahead and take 65 plus 25, and I end up with 90 pi inches squared. So there you go. That's how you find surface area of cones and pyramids.